welcome. This is the Kentucky Center for Mathematics. We are talking today about geometry. This is the third in a series. You can always find us at our website. So I am Kelly Dillon, the Executive Director for the Kentucky Center for Mathematics. Always look forward to having you guys reach out to me if there's anything that you're thinking about with regards to math education at your Kentucky school. We would love to partner with you. Our website might be the best ever, maybe the best website out there. And I say that boldly and brashly because I truly believe that if you want resources for math education, this Kentucky Mathematics site is a place where you would want to go in and peruse. So our agenda today is talking about the standards. You know, we like to also do a little bit of research. And today, our research happens to focus on schema. I think that is especially appropriate when we're talking about geometry and trying to connect the dots with regards to making long-term, deep conceptual understanding with regards to mathematics. My focus today is on volume, entry point, and 5th grade. And then I'll be talking about two-dimensional measurement with regards to circumference and area. So both of those with some resources that I think that you're gonna love. So I always start with an activator. I wanted to share a book that I especially love. This one happens to be on my shelf all the time because what it's got is when you're doing presentations such as these, and many of you, I see you guys out there are teacher leaders, that book has some really good ideas on how to launch and how to summarize. But one that I love, I've done it several times, is this idea of point of most significance. I call it a POMS. And at the end of this presentation, I'll be asking you to type in your point of most significant. What was your takeaway from today's presentation and the information that I have presented to you? So there's no right answer. All kinds of answers are ones that matter, but you can type in, okay? And thinking about that at the end, this will be something that's in the back of your mind. What might be your point of most significance as we're talking today? So as always, here at the Kentucky Center for Mathematics, we link back to our Kentucky Academic Standards. And I, again, give a shout out to our KDE folks and those that worked on this project of rewriting the standards. And we're updating, I think that's probably a better word. We're updating our standards for Kentucky, but they're great. So you can see that we're gonna be focusing here thinking about relating volume to the operations of multiplication and addition. And you and I will be talking about in what ways is volume multiplicative and in what ways is it additive, because this is important as kids think about it. And we want to think about it for kids. Amy says that the math standards are the easiest to read. I agree. Of all the content standards, and these clarifications, Amy, are fantastic. In addition to volume, we're going to think about volume at the 6th grade level when all of a sudden the sides get to be rational numbers. So what happens when instead of an edge of 1, it becomes an edge of 1/2? Of course, our answer to you is that we continue with that same schema. How did kids learn it in 5th grade? Then all we're doing is we're just changing the kind of number that we're manipulating with and giving it a second year to really smolder and to think about that. And then, we are going to be moving on to 7th grade. And in 7th grade, we're going to be talking about those very special geometric shapes called circles. They have properties that are so important, but my favorite part is, what does pi really mean? And so we've got some great visual images for that. But I want to start with this quote, and I'll be looking for you guys here in the chat to give me some input. But notice what I thought was important for our research. I'm going to let you take a minute to read that. It is conceptual understanding in math that has been our life goal. So I'm looking across at the screen of all you folks that are here. And I say to you that we know that our job is to really work and have kids really deeply understand the mathematics. I was really taken by this research site called mindresearch.org because it really helped connect the dots with regards to the research and to geometry. I thought this was a really nice connection. I'm gonna start by showing you this video from the mindresearch.org site, and it's gonna lay the foundation for how we're gonna look at the lessons that I'm going to be presenting. So a little research. Giving that a click and there we go. All right, I'm going to increase this and let's think about this idea of schema.
As students go through the learning path, they're building schema. We're constantly building schema. And to help us gain a better understanding of how concepts become disconnected, let's think about how students typically think about the math that they're learning. We have a set of standards that we're teaching to students, and then students look at these things often in isolation. They see them as bits of knowledge and they shove them into compartments. Fractions over here, whole numbers over there, place value goes someplace else. The problem with thinking like that is that there's no connection. When we get students to really think about the math, to consider the concepts in relation to the other things that they know, we can help them take a list of information and make it into a web of knowledge. This is how schema is built. Students connecting the individual learning to create these neural pathways to learn.
So that's our goal at the Kentucky Center for Mathematics, and that is that it really does help us to connect pieces and parts. So I was wondering if someone could unmute their mic in thinking about this idea of schema. Why is it important in mathematics for us to help students connect the pieces?
Well, one thing I think is that math is the one subject that is so logic-based. And if you don't make sense of it, you know, and helps have students have time to make sense and make those connections, then we start losing them as far as really seeing themselves as mathematicians and understanding that they are mathematicians.
I love that, and especially that idea of efficacy, right? We want students to think about the pieces. And so I think that that's why it's important. I felt so compelled to add this to our geometry section because I'm going to show us reasons why kids should really have the deep conceptual understanding with regards to why geometric formulas are what they are. And so we're really going to be looking at those ideas. So let's take a look at this. And here I'm going to say, so let's build some schema. All right, let's build some schema with regards to these mathematical concepts. This is one of the activities. I'm going to go backwards. This is one of the activities that I want us to be able to take a look at together. So I am going to highlight this and I'm going to add it into our chat box. And so I'm doing a copy paste and I'm going to hit that for you. And here's what I'd like for you to do. I'd love for you to click on that link. Dee, if you can tell me, am I rolling? Is that looking pretty good? Is it easily clickable? Can somebody tell me that? What is
it works and I'm in.
Yay, yay. All right, so all I really want you to do is I want you to launch it from a student view. So I want you guys to click student view, student preview, and I want you to click through as I am clicking on my screen. I want you to click through and to think about building volume. So this is an activity from Desmos. So I want to start at the beginning while you're clicking through. I'm going to let you do it first and then I'll come behind you. But this is an activity from Desmos. It is the entry point with regards to volume. And indeed, we're having kids build this idea of volume. Now, as a math purist, I do want to mention that the way that they kind of added, it's Roger, and is a little cutesy for me. But what I did love is it is 100% the conceptual understanding of volume. So again, this helps kids link it to schema. Like Jennifer said just a minute ago, she said that's a really, you know, the video helped us to think about schema. Yes, Jennifer, or if you'll click that link, and then in Desmos it says student preview, that's what I'd love for you to click on. So if you'll click on that student preview, then you'll have this screen that I'm showing you on my share screen. So I love that you could, this is Google Classroom available. You can have students interact with it. They submit the information, and what a great way to help kids in 5th grade thinking about what is the volume, because we can build it and we can see this. And again, we could create a count, we can give a class code. Lisa did something similar to that yesterday. That class code was super fun, super fun. And so I thought that we may enjoy something similar to that. So I'm gonna go back to my presentation and say, all right, so that was for geometric volume. In the chat, there's a couple things that I'd like for you guys to think about. And that is, why is it important for students to interact with some technology in order to help build their conceptual understanding? Why does that help students? You might want to unmute, or you might want to just type in our chat box. Kids are going to interact and understand about volume. They're going to click within this Desmos. We know Desmos is fantastic. And so we're wondering, how does this help kids build schema? Why is this technology important? That's right. Amy says, look, non-traditional instruction days are really our new reality. And so this will help kids to see volume when they can't actually be in their classroom with their teacher.
Well, volume too, your numbers get big fast, and you know, even the most well supplied classroom may not be able to make something to really put it all together.
Jennifer, my former life is that I was a K-12 math specialist in a district, and we had to supply teachers, every student needed a bag of 64 cubes. And the idea was that kids were going to build a layer and then build another layer and build another layer. And so you're right, Jennifer, there was just a lot of cubes that we had to give kids in order to be able to manipulate and work with this. And so in this technology, it actually helps us to explore. And we always say here at the Kentucky Center for Mathematics is the technology helps us for the what if, right? It helps us for the what if. So indeed, Jim from North Carolina says being able to verbalize what they see, trying to help them make sense of it, and then typing it in helps them to really come to a conceptual understanding. I 100% agree with that. And so I'm going to continue with this same idea, because I'm thinking that you guys, this is going well in terms of being able to go to the link. So I'm going to find my next online tool that I adored, which happens to be from my favorite organization ever, which is the National Council of the Teachers of Mathematics. And I'm going to clear because you can see that I was playing. And so if you will click on that link, then what you're going to be able to do, and what I have done here is this allows us to think about what is the volume if this is the net. So watch how cool this is. You can go ahead and play a little bit while I'm kind of showing you. So I'm going to add a cube. There's a couple things that I love. I love that the cubes have 3 colors so that I can see the 3 faces. One of our standards says that volume is made up of many units of something called a 1 or a unit. And so this is a unit cube. And then when I click it, notice that I can see that I have a row of 4. Then I continue to click it. Now I have 2 rows of 4. 3 rows of 4, 4 rows of 4, and 5 rows of 4. And then what I really loved about this is when when it's asking you a question, all right, so build this, fill this net with the volume. I can say, all right, well, I've seen with individual cubes. Now I can just do another layer and another layer. And so think about how powerful that is with the cubes. Jennifer says, it says we can't find that. And so my question is, yeah, Lisa says it worked for me. Yep. All right, beautiful. So Cindy says the color coding of the nets match the cubes. Very cool. Yep. All right, good. Some of them saying that we're working. Excellent. So copy and paste that link and see if you can make that work. I know you'll love being able to mess around in that tool. Again, thinking about students being able to work and to make that, make some connections with regards to that. So thinking about doing the volume, that's very important. So here is, we love Graham Fletcher here at the Kentucky Center for Mathematics. And the power in this one happens to be just the notice and the wonder. And I want you to stop. So 2 words, notice and wonder. And so we're going to head to this website. And I am going to hit the play button. There is no sound. So don't worry, say, oh, she doesn't have sound. No, there's no sound. Eyes on the Domino sugar cubes. All of a sudden I'm taken back to my grandmother's house when she drank tea. And I got to reach into the sugar bowl with the tongs and to put the cube in her tea. What a beautiful memory. So here we go. What do you notice and what do you wonder? There it is. That's it, right? Just what do you notice and what do you wonder? So I'm looking in the chat box for what you're noticing and what you're wondering, but I'm also looking for that brave soul that's willing to unmute and say to me, what did you notice and what did you wonder? It says that it was 1 pound. What does that mean? What are sugar cubes? I love that. What are sugar cubes and how many might be in that box? I noticed that both the box and the cubes have 90-degree angles. Look at Madison. I wonder how many cubes can fill that box. I wonder, from my perspective, I wonder, obviously they're going to have to be whole number cubes, right? Are the cubes packed tightly? Or are they just dropped into the box and I can shake them? A variety of things. But you can see that this is one of Graham Fletcher's, the ways that he has kids think about that. I want to show you my screen with regards to a recording sheet. So in your packet of information, I've given you this sheet because Graham says that when we activate that wonder and noticing for kids, that they can really get to that mathematical concept. So what do you notice? What do you wonder? What might be your main question? Could you make an estimate? Because the question did ask us how many of those sugar cubes. Could you make an estimate? What information do you want to know? Do you have an answer? And then of course, look at that beautiful, I'm going to show my work. Thinking about schema, right? So if I had to figure out how many sugar cubes were in that box, I would really have a great understanding of volume. I will have explored it and I will have attached it to my schema. And as I'm looking in the chat, it says very good. It wasn't until the box was turned did you know how much there might be, because you need to know those dimensions, the 2-dimension, and volume is a 3-dimensional geometric shape, right? So thinking about volume has 3 dimensions, And so I'm really thinking about it in that way. So I know you'd enjoy that Graham Fletcher one. Here is his recording sheet, which I think always is important to give kids a reason to watch something. So obviously those Graham Fletcher videos are meant for you to go back and back and back and back and hit replay and hit replay and hit replay for the kids to be able to have some idea. And here's another one, thinking about volume again. And notice how he has this one in here. And I'm going to ask that question yet again, circling back again, trying to have us give some schema. What do you notice? What do you wonder? Everyone looking for an answer, typing it there in the chat box. Ah, we are so glad that that box is clear. Amy says she thinks that it just indeed might be a cube. So Madison says, I wonder, are those blue ones and the red ones the same size? It's interesting that when we get to this with regards to a 5th grader, they have some frame of reference with these kinds of cubes, because in a good elementary school, there is all kinds of these cubes that they've used for counting. And so Carrie says, from a child's point of view, they may ask, why is that one cube outside of the box? Exactly. So the idea is that I have presented for you 2 different ways to be able to build this idea of volume, to activate wonder and to activate this curiosity with regards to geometry. And part of this idea that I'm proposing today is to say, I don't want you to go in there and say, okay, the formula is la, 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 and now let's just crunch some numbers, right? Volume is about developing the schema to understand that it's, that it has a way, that you have a way to fill a box in with real world items, and it is worth the time and effort to explore for a day, explore for several days, these ideas, so that kids can build those schemas that really lead to, right? Then they tell you that it's length times width times height. How many cubes are in the bottom times how many layers? I would love for some of my middle school folks, thinking about Dee, thinking about Cindy, thinking about Leah, thinking about some of you folks out there that are middle school folks that have actually, I've taught this for so many years, that it is the wonder that I love. So talk to me a little bit about, why is it important that we have kids do the hands-on before we let the cat out of the bag with regards to the formula?
From my perspective, it's that the formula is a formula for a specific figure. And so what happens if they don't have experience is actually literally filling out what volume is, experiences of what it means in terms of filling a space. Then they don't grasp that all volume is not the same formula, just like if we don't give them experiences understanding filling flat surfaces as area, they just assume it's all this one formula. And so when you ask what area is, they say length times width, except that only work for one figure. The formulas only work for a specific figure. And it's understanding the concept of what volume actually is, and that filling things in, taking things out is what builds it.
So my favorite thing is that I am surrounded by the best mathematicians in the world, and Dee being one of them. And that's why, I mean, there's just certain things. And so we say at the Kentucky Center for Math, you can't skip this step. This is a step that you need to skip because we're building that schema. On that same note, I'm going to show you a series of books. This is the Cindy Neusch-Wander series of books with regards to all kinds of geometric figures. And in my soul, I can't even begin to tell you how much I love these books. Have read them for years to students, have made them cornerstones of the mathematics that I do with middle school students. And I can tell you it pays off year after year after year. As a matter of fact, kids will come back to me and tell me that some of their favorite memories are around these circumference series of books. So the one that I'm highlighting today happens to be Circumference and the Dragon of Pi. And there are lots of resources out there on the internet with regards to these books. But the one that I found that that I really did love is this one, and that it's from someone who's kind of annotating the book, and she's called Math Understood, and you'll see why. Bear with me, as I don't want to show the whole thing because it's too long, so I'm going to show you 3 different clips, and so bear with me as I'm dragging the cursor along, but I want you to see where we are.
Welcome to Math Understood, and today we are going to be exploring circumference and diameter. We are going to be exploring these concepts through the book Circumference and the Dragon of Pi, a math adventure by Cindy Neuschwander, illustrated by Wayne Gihan. Again, here's the title of the book, and I just want to highlight how we're going to have an awesome math adventure. Circumference and his son, Radius, sat in the shade of a tree, enjoying a delicious midday meal. Partway through the lunch, Circumference grabbed his stomach and doubled over in pain. "Oh, my belly," he wailed. "It feels like fire. Radius, run to the castle, find the good doctor, and get me a cure."
So I'm going to stop it right there because I really did stop it when I was reading it to students, and I would say, so what is the play on words? What do we know? Kids, depending upon what year we read it 6th grade, kids didn't have any background knowledge with regards to circumference. In 7th grade, they did, but we would circle back to it. I'm going to move forward to a section of the book that then I think is super cute, and this happens to be in your handout from the Utah Education Network, some materials to use with regards to this book.
Divide so a number can be found. Every circle, great and small, the number is the same for all. It's also the dose, so be clever, or a dragon, he will stay forever.
So I'm going to pause it. I'm going to read it one more time, and I'm going to see if you guys can type into the chat box, because I know that what I've done is I've pulled some of you from elementary that may not have that may not have ever seen this before. So I'm going to read it to you. It says a circle's measure. Measure the middle and circle around. Divide so a number can be found. Every circle, great and small, the number is the same for all. It's also the dose, so be clever, or dragon, he will stay forever. And of course, Radius is trying to get a cure for Circumference's stomach. So what is it that they're referencing? Measure the middle and circle around, divide so a number can be found. What are the kids looking for in this story? I'm watching my chat. I'm wondering if someone's brave enough. And I know some of you are laying back. Yay! Look at it. Yay. You got it, Madison, Jacqueline, Becky, and the whole crew. You're exactly right. That is the geometric constant pi. And that's indeed what it is. And so I'm going to drag it forward just to show you one more little piece that I think is super cute. And we can actually see it as she's working on it right there. And it happens to be that
Pies. She measured strips of dough into equal lengths with the
go back to
center of the circle. As he ran through the kitchen, he saw his cousin Ladyfingers. She was baking pies. She measured strips of dough into equal lengths with the span of her fingers. "Help me finish the last pie, please," she pleaded. Radius thought about Sim's wheel. He arranged the strips on the pie like the spokes. There were 3 strips left over. He draped them around the rim of the pie pan. 1, 2, 3 strips go almost all the way around the edge. "Pinky, may I have a little more dough?" asked Radius. Pinky was Ladyfinger's nickname. Ladyfingers handed him another strip of dough.
I'm going to stop it right there, but you can see how beautifully the images in the story illustrate that the circumference of a circle is 3.143 and a little more of the diameters, and that's how they go around. What a beautiful way. If I was a kid, notice how this would help me to build my schema. So I want to go back to that word schema, and I want to talk about literature. I want to talk about actually giving kids the opportunity to do activities like this. And in the chat, I want you to profess, why is it that we must do this? Why is it that this is the kind of activities for understanding circumference that we must do as math teachers? You can unmute. I'm watching my text. I'm watching my, making connections, conceptual understanding. Kim links it back to something that's very important. Kim says it reminds me of the three aspects of number, thinking about how we really need to do a great job of building the conceptual understanding. And Jennifer, you're 100% right. Math should make sense. You are 100% right. Math should make sense. And that's our goal, is to have students do activities where math makes sense. So this is an interactive tool. Again, I'm going to keep rolling with this. Jennifer, I'm hoping that there's something about it that makes sure that you can link it. But notice that I want everyone going to this interactive tool. I think we're having a good time going to these sites, but I'm going to go ahead and show you a couple. One, this is again from our handy dandy NCTM. You can't go wrong when our friends NCTM put something up there. You know that it is quality stuff. So take a look and see what's happened here. If we just got finished with circumference and kids are looking for relationships, notice that this tool, I can have a diameter of 6, and look what happens down here. There's 1, 2, 3, and a little bit more. We know that that's the 0.14 with regards to the ratio, right? It's pi happens to be a ratio. It doesn't have a unit. It's a relationship that occurs in circular objects. I'm going to go here to investigation, and I'm going to begin to do the what if situations. Again, the power of technology is that we are able to think about the what if. So what if the radius is 1? What would the diameter be? What would the circumference be? And what would the area be? And I'm going to add it to my table. So then I say to myself, I wonder if the radius is 10. What happens there? Notice that I have a multiplicatively bigger numbers. Beautiful that kids can begin to see that understanding, but I think you're really going to enjoy it. This is my favorite part. So we can see a question, and then you go, well, I wonder what it is. So how long should the rope be? The rope needs to eat this many square feet. Could somebody unmute and say, where am I looking up here? I'm going to be able to move this heat out. But the problem solving part of it, the schema part of it, is I've got to figure out what is the question asking me. Who can help me with that? What should I be looking for? How long should the rope be if the goat needs to eat that? You're right, Rachel. Thanks for helping me out. I'm looking right there to say that many square feet of grass. So watch as I do. All right, so what was my magic number? 250. 4.7. Hot dog, I got it. So it has a radius of 9, a diameter of 18, a circumference. So look at that interactive right there. And so I can put my information in there. Notice how I'm going to have to use a unit. How long the rope is that? Is that the units are so important? Is that feet? Is that square feet? All right. Cool. Notice how that works. I adored that. As I was presenting that, I thought, oh my gosh, that is something that kids absolutely have to be able to do. So fantastic. In the chat box, how about let me know what you like about that tool? What is it about that tool that helps to build schema? Looking for everyone to give me an answer. I'd love for, I think there's 20 of us here on here today. Yep, over 20, there's 26 of us on here. So if you could type in there, why do you love that? What is it about that one that would help students build schema? Multiple ways to look for the numbers, noticing the relationship between the numbers, the connection that could be made in the table. That's exactly right. I think that looking for the patterns, remember that one of our mathematical, our standards for mathematical practice is to look for patterns. And so that is so important. They can visualize it. Madison, there would be a lot of angst with regards to creating that if it was just paper and pencil. But with regards to the technology makes that easier. And Cindy, yes, those numbers are proportional. I can begin to see them as they're rolling in, and I can begin to make these thinking about patterns and how I might want to do those, thinking about it. And it really begins to solidify in my mind the relationship between that, right? The relationship between radius and diameter, the relationship between diameter and circumference, and the ratio and the relationship, of course, with area to all of those. So I'm clicking on to my next one, thinking about my next slide. Things are loading slowly, so I apologize. I'm gonna click back out of that. In the interest of time, I'm watching that we're at 2:35. I added another one with GeoGebra. This is a fun one. It actually takes the circle and it peels it and shows the relationship of the how we derive area with regards to peeling it and from something that we know before, which happens to be a triangle. And so that one is worth an extra watch. But I love this visual representation of area. So thinking about how important it is for kids to get these visual representations of area and how it comes from that. So this will be the last one that I'm going to show you. I hope that loads quickly. And I'm going to, again, in the interest of time, drag this one.
Hello friends, marker.
Quickly, and I know that I'm headed here to take a look at it.
To be out just like the pizza slice. In the similar manner, do the cutting of all the 8 parts of the circle. After cutting, we will get 8 equal parts of the circle. Now let's arrange these 8 parts into a rectangle. See this manner.
And so as she continues with this, what you're going to see is that she arranges a circle in a very familiar shape for students, which happens to be a rectangle. And then we take them through this idea of the fact that if the area of a rectangle is length times width, then the area of the circle can be that we can derive the area of the circle using that same logical thought. I will tell you that I did enjoy the language that she was using. I enjoyed that accent on my ears, and I think that it's important in this global community to show kids that kids do math everywhere, right? Kids do math everywhere. And so I loved that video. So the question that I had for you as we were going through this is, how do we build schema in regards to geometric concepts? I think that that's important, and I hope that one of your takeaways might be this idea of how important that is for kids, for us to help kids to connect the dots and give them time to do this, and that I profess that it is especially important to do it when we are in our topic with geometry. So with that, I'm going to take us back to this idea of POMS, which is points of most significance. And I'm going to ask you this question. What is your point of most significance from today's session? So if you will type that into the chat. Amy says that it's providing students with experiences, rich experiences outside of paper and pencil. Carrie says that this is an example of technology is engaging and allows for those connections. You're exactly right. Kim says, I wish I would have learned geometry this way. I needed you to be in, those of us that are at KCM that were middle school folks, you needed to be in our math classrooms because this is what we did. Again, referencing a couple of my friends that are on today. Kim, you're right, point of most significance is hands-on connection. Absolutely, hands-on connections, and presented in multiple formats. You did see that I was presenting the volume, which I knew was our entry point, in multiple formats so that kids could get to it in different ways, and making sure that we do that web of knowledge. Thank you, Julie. The web of knowledge to build our schema really makes a difference. So it is important from the Kentucky Center for Mathematics that we bring you lots of great Zoom sessions where you get the idea of how to present important mathematical concepts in a way that is rich and builds schema for students. And so you just need to hang with us Monday through Friday in the afternoons at 2 o'clock, and you will be presented with lots of expertise from folks from across the state of Kentucky. Lisa, I'm glad you like the circumference. That's my favorite series. It's near and dear to my heart. Tomorrow, Dee is going to pick up where I left off, which was in two-dimensional geometry. We are headed to all things circle and prisms, and I can only imagine what else she's going to share, tomorrow. And you can find us here at the Kentucky Center for Mathematics at our at our website, where we house all of our virtual materials. You don't ever have to go looking for the video, the presentation, or the handouts. They're there in one-stop shopping. And this is me. I'm Kelly DeLong. I am the Executive Director for the Kentucky Center for Mathematics. I love to hear from all of you from across the state of Kentucky and across the nation. All you need to do is just give us a shout out. Tomorrow, I'm looking at the chat. So tomorrow, the elementary standards were Monday and Tuesday. Today was the bridge from elementary at 5th and 6th. Tomorrow is 7 and 8, and high school is Friday. So we're spanning the whole thing, and we want to encourage you to come to all of those. So thank you so much. And Lisa enjoyed those virtual links. So I want to give a shout out to Lisa, who was brave and put them in the chat. And I was like, okay, let's see how that happens. That worked out great today. All right. See you guys.